Narrator, calm, powerful voice. In 1929, scientists expanded their understanding of the universe with discoveries that would forever change our view of existence. They realized that all matter, everything we see, including ourselves, is made from elements forged in the hearts of stars. By 1957, they had unraveled even more. The sky, once seen merely as a glittering spectacle, became recognized as a living window into an incredibly dynamic universe. A universe that shapes our very existence in ways we might never fully comprehend. Across the vast expanse of space, events unfold that sometimes affect us directly, though we may remain oblivious until their consequences finally reach our fragile world. Today, one of the most fascinating celestial giants under close scrutiny is Betelgeuse, the iconic red supergiant star, shining within the constellation of Orion. For millennia, Betelgeuse has stood among the brightest stars in the night sky. But recently, it has begun behaving in strange and alarming ways, its light flickering with violent, unpredictable pulsations, intriguing and unsettling astronomers worldwide. Betelgeuse is no ordinary star. It is a colossal titan, estimated to be nearly 20 times more massive than our Sun. From Earth, it appears as a simple reddish dot, but its true nature is far more awe-inspiring. Situated approximately 640 light-years away, Betelgeuse is, in cosmic terms, astonishingly close. If humanity could travel at the speed of light, an unimaginable feat, it would still take over 6 centuries to reach it. And with current technology, the journey would take more than 12 million years. This staggering distance underscores both the unimaginable scale of the universe and the monumental power of Betelgeuse itself. Despite its distant, serene appearance, Betelgeuse is anything but peaceful. As a pulsating red supergiant, its brightness varies dramatically over long cycles, swelling and shrinking, growing brighter and dimmer. The shortest of these cycles lasts about 185 days, while the longest stretches over 2,300 days. These changes are not random. Astronomers have observed patterns in Betelgeuse's behavior, marked by variations in its so-called V-band magnitude, a measure of brightness. In February 2021, Betelgeuse registered one of its lowest V-band magnitudes, dropping to about plus 1.614, a significant decline from its typical brilliance. Its reddish hue comes from its cooler surface temperature, hovering around 3,500 Kelvin, much cooler than the Sun's 5,500 Kelvin. Despite its massive size, this lower temperature results in a lower overall energy output, causing it to appear dimmer than our Sun. Yet something unusual is happening within Betelgeuse. Scientists believe that its helium shell may be undergoing a crucial fusion phase, as the star progresses through the final stages of its stellar life cycle. Normally, hydrogen fusion powers a star like Betelgeuse. But as hydrogen becomes depleted, the core contracts, and the outer layers expand, the red giant phase. The accumulated helium then ignites secondary fusion reactions, producing carbon, oxygen, and other elements, releasing energy, causing the star to expand and contract in visible, rhythmic cycles. This heartbeat of the star often leads to powerful mass ejections, as Betelgeuse sheds its outer layers through fierce stellar winds, creating a dazzling, flickering dance of light across the sky. To understand these changes, scientists employ techniques like photometry, measuring changes in brightness, and spectroscopy, analyzing the light across different wavelengths to reveal the star's composition, temperature, and movements. By piecing together this data and using sophisticated computational models, astrophysicists can simulate Betelgeuse's inner workings, exploring the delicate ballet of forces that drive its dramatic behavior. Beyond fusion and mass loss, convection also plays a critical role. Deep within supergiant stars, energy moves through vast cycles of rising and falling material, creating enormous, turbulent currents that carry energy to the surface. Fluctuations in these convection currents can cause periodic changes in brightness, adding another layer of complexity to Betelgeuse's dance. In some stars, close companionship with another star, a binary system, can dramatically alter their evolution. Material transfer between two orbiting stars disrupts equilibrium, triggering brightness changes, expansions, and contractions. Although Betelgeuse seems to be solitary, the possibility of a hidden companion has not been ruled out, a mystery that continues to fuel scientific speculation. But there's another, far more sobering possibility. Betelgeuse may simply be nearing the end of its life. Massive stars like Betelgeuse constantly balance the crushing force of gravity with the outward pressure from nuclear fusion. But as their nuclear fuel depletes, gravity begins to win. The core contracts, growing hotter and denser, igniting furious fusion of heavier and heavier elements, until iron forms at the core. Iron, unlike lighter elements, cannot release energy through fusion. Instead, it absorbs it, dooming the star to an inevitable collapse. In a catastrophic moment, the core can no longer support its own weight. Gravity crushes it inward, triggering a supernova. A stellar explosion so powerful that it would outshine entire galaxies. Should Betelgeuse go supernova, it would produce a burst of light visible from Earth even during the day, a cosmic beacon lasting for weeks or months. Thankfully, Betelgeuse is distant enough to prevent catastrophic damage to Earth. Yet, a nearby supernova is no trivial event. Gamma-ray bursts, high-energy events associated with supernovae, could strip away parts of Earth's ozone layer if a star exploded much closer. The electromagnetic pulse could disrupt electronics and communication systems. Weather patterns could shift. Ecosystems might suffer. Humanity would feel the echo of a distant death. And if the supernova left behind a black hole, the transformation would offer yet another spectacular chapter. While a black hole 640 light-years away would not pull our solar system apart, the intense radiation from its accretion disk could still affect nearby environments and atmospheres. The life and potential death of Betelgeuse offer us a rare, breathtaking glimpse into the grand forces that shape the universe, and remind us of the delicate balance that sustains existence. Betelgeuse's ongoing fluctuations and its potential collapse into either a brilliant supernova or a silent black hole fire the imaginations of astronomers and dreamers alike. Through Betelgeuse, we see the dynamic, ever-changing nature of massive stars, a process of death and rebirth that has seeded the universe with the very elements that build